This is the continuation of test number 2, version 1, but now we're doing the backside, numbers 6 through 10. So for number 6, this is still a solving problem. It only has one trig function in it, so I know I don't need to factor. I'm just going to get that trig function by itself. I'm going to add 4 to both sides. Then I'm going to divide by 3. And because the trig function is squared, I'm going to square root both sides. Now, when you square root both sides, you have a positive and negative. Then what is the square root of 4? That's 2. The square root of 3 just stays as square root 3. Now, on my unit circle, I have no values that are cosecant. But cosecant is the reciprocal of sine. So I can flip cosecant to become sine, which means that I'm going to flip my answer to be positive or negative square root 3 over 2. So for this problem, I'm finding where is the y value? A positive or negative square root 3 over 2. So we have pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. So all the pi's over 3's. For number 7, we're also solving. Now once again, I have a double angle formula. I have cosine of 2x. And there are 3 that I could choose from for cosine of 2x. Now this problem, its other value is just the cosine x, so I'm looking for the double angle formula that only contains cosine. So that's going to be the second one here. And I'm going to try to get this equal to 0. All that I need to do is subtract 2. And I'm going to combine this -1 minus 2 to make -3. Now this is a factoring problem, and it's factoring with an a value that's greater than 1. So what you do is you do 2 times -3, which is -6. So I want things that multiply to -6, but add to be 5. That is -2. Oh, I'm sorry. That's actually +6 and -1. So now we are going to replace the 5 cosine x with 6 cosine x and -1 cosine x. So this splits off into 6 cosine x and -1 cosine x. And we're going to just bring down the rest of that. So we have the front term and the last term, we just bring those down. Then you do factoring by grouping. So if I look at these two, I have a 2 and a 6. Those can both be divided by 2. And then they both have a cosine. So 2 cosine x goes out in front. And what's left over? So the 2 divided by 2 cancels and you get 1. Cosine squared divided by cosine leaves me with cosine x. 6 divided by 2 is 3. And cosine x divided by cosine x goes away and cancels. Then we can do this next part. I have -1 cosine x minus 3. They both have a negative, so I'm going to put the negative out front. And they have nothing else in common. So I'm going to write what's left over. I guess I could put a -1 here if I wanted to. I took out the -1, so I'm left over with cosine x. -3 divided by -1 is a +3. Now for GCF, for factoring by grouping, these should be the same. So one of my factors is cosine x plus 3. My other factor is 2 cosine x minus 1. You have the zero product property, which means that I can split it up. Cosine x plus 3 equals 0, and 2 cosine x minus 1 equals 0. Subtract 3 on both sides. This is asking me where the x-coordinate is equal to -3. That never occurs on the unit circle. So there's no values of x that work. For the other side, I would add 1. And then divide by 2. So I'm looking where cosine x equals a +1/2. So where is the x-coordinate a +1/2? That's 5 pi over 3 and pi over 3. So we finished up all the solving problems that were on your test. Now we have to do the double, the difference, and the half formula for the 2 triangles that they gave us. So they told us that tangent of A equals 3/4, and A is between pi and 3 pi over 2. So if I'm going to sketch triangle A, it needs to be in between pi and 3 pi over 2. So that's in the 3rd quadrant. And the angle is always closest to the x-axis. Now tangent tells us opposite over adjacent. So the opposite is 3. The adjacent is 4. And you can do the Pythagorean theorem to figure out that other side, which is the a squared plus b squared equals c squared. Or we had talked about how 3, 4, and 5 always go together. Now for triangle B, Triangle B is between 0 and pi over 2, so that's the first quadrant. And my angle is up against the x-axis. And it tells us sine of B is 5 over 13. So sine is opposite, so the opposite side is 5. The hypotenuse is 13. And you can do the Pythagorean theorem to figure out that third side. You might not know automatically what goes there. So you have 5 squared plus b squared equals 13 squared. You have 144, and when you take the square root, the other side is going to be 12. So if I'm trying to find, for number 8, the sine of 2a, the sine of 2x formula is 2 sine x cosine x. But we replace the x with the a that's here. So it's going to be 2 sine a cosine a. And we just need to fill in what those values are. Now I'm only going to be using triangle A. So I'm only using that triangle. What is sine of A? Well, sine is opposite over hypotenuse. So that's going to be 3 over 5. And cosine A is adjacent over hypotenuse. So that's going to be 4 over 5. Now, when you multiply fractions, you multiply the top times the top and the bottom times the bottom. Now, 2 is technically in the top because it's secretly over 1 there. So I'm going to do 2 times 3 times 4, which gives me 24. 1 times 5 times 5 gives me 25. For number 9, I have the cosine of A minus B. So I'm going to use my formula sheet to write down that cosine of A minus B. It's this one here. Cosine A, cosine B, plus sine A, sine B. I'm going to set up my parentheses since I know I am plugging in values. Now, every time it says A, I have to use triangle A. So cosine of A would be adjacent over hypotenuse, 4 over 5. Cosine of B, I would have to use my triangle B. So A over H, 12 over 13. Sine of A, go back to triangle A, O over H, so 3 over 5. Sine of B, you're going to use triangle B over here, O over H, which is 5 over 13. Now remember, when you do fractions, or actually when you do any problem, you have to multiply before you can add. So we're going to do 4 times 12 is 48. Five times 13 is 65. 3 times 5 is 15. 5 times 13, 65. Then you'll do 48 plus 15. $63, and then they have the same denominator, so you keep it as 65. Now for number 10, we're doing a half angle identity. Or sorry, not an identity, half angle formula. We're finding the cosine of b divided by 2. So we're going to use our half angle identity, which is right here. Positive or negative. 1 plus cosine x divided by 2. Now I'm going to be using triangle B when I do this problem. We're only referencing this one. So what is the cosine of x? So cosine is a over h. So I have 12 over 13. The first step is to get that common denominator. So I have a 13 here, so my 1 is going to become 13 over 13. And that gives me 25 over 13 divided by 2. Then we multiply by the reciprocal. 25 times 1 is 25. 13 times 2 is 26. And then our last step is just to decide whether it has to be positive or negative. Now, since we're doing half of angle B, we're using the half angle formula, we are really, instead of trying to find something between 0 and pi over 2, we're really trying to find things between 0 and 45. So is cosine positive or negative between 0 and 45? Well, it's positive. So my final answer is a positive square root of 25 over 26.